Здравствуйте, and welcome to Project 2.8 DC Motor Control. The goal of this project is to control a simple DC hobby motor in two directions via an H-bridge chip. There are 5 main hardware segments of this project, the first of which is the Arduino. The Arduino provides the main control for the circuit and connects all of the other sections together. The second segment is the LCD display. This display provides the user a simple, visible reading of the current state of the circuit. The LCD displays the current gear followed by the duty cycle the motor is receiving. The third segment is the supplemental power jack. This allows the use of a separate power supply for the motor not to tax the Arduino too hard and allow the use of voltages less than 5 volts. The fourth segment is a motor control chip. The 754410N is a dual H-bridge motor control chip. Through 2 of its connections, the direction of the motor can be controlled, and through the final connection, the speed can be controlled by variable average voltage of PWM. Note the flyback diodes located to the right of the chip. These will be discussed later with the discussion of H-bridges. The final segment is a DC motor. The motor is designed for small loads and basic hobby projects. It is very suitable for this kind of small project. There are 2 possible displays for this project, the first of which is the aforementioned LCD, and the second is the serial monitor. Here's how the serial monitor works. It functions both as an input and output. You see, if you input a number 1, that's forward, 2, that's reverse, 3 is neutral, and 4 is brake. Then you put that number in, followed by a comma. Then you have to input the PWM speed, 0 being all off, so the motor's all off, 128 being half on, and 255 being all on, a 100% duty cycle. This can then be sent, and you get the same information that you'd see on the LCD. This provides an extra backup. There are a few pieces of data that cannot be sent. For example, any number over 255 for the second variable will not work, and result in an error message, and any number over 4 in the first one will also result in an error message. This does not break the circuit or break any of the software. It just needs requesting another version with correct information to be sent. There is one other way to control the circuit. It's via a processing terminal. This dashboard allows a graphical, simple way to send the data via buttons and a slider bar. It's simple. You just click on the one you want, then you slide the bar to whatever speed you want to go to, click send, and now it's going that speed. It's that simple. Here is the H-bridge circuit. When 2 sides and opposite corners are turned on, it flows from top right to bottom left. If it is inverted, then it'll flow in the opposite direction. This allows us to switch the direction that the motor is turning. This is now very useful, because we can now control the direction. There are a few other states that this can be in. Neutral and brake. Brake applies a field to both ends and will stop the motor, while neutral will allow her to come to rest naturally. However, there is an issue. There are no flyback diodes that allow the field to dissipate. This is needed. So, 4 power diodes, as you can see here, are added to the circuit, allowing the safe dissipation of an electromagnetic field.